Denver to deliver this John Porter distinguished lecture. So I probably don't need to really introduce Professor Jurafsky because everyone knows he's a famous Bible textbook, the speech recognition and natural language processing. Right, and then also Farley and I have to teach a lot of things. He has been developed in our NLP process, like semantic role labels, the distance supervision, and many others. Yeah, so Dan has been get a lot of awards, so including AS Fellow, A and S Fellow, and also ACL Fellow. So his recent book, The Language of Food, Linguistic Risk Menu, was also selected as the finalist for the James Gregg Award. So Dan research went from many different areas in NLP, and I especially like his work in the intersection between NLP and social science and behavior science. So without further ado, let's welcome Dan.
Thanks, Kaiwei. Thanks, everybody. I'm excited to be here. This is very fun. I love coming to LA. So I want to talk about ways that we as computer scientists can help solve social problems and try to contribute to making the world a better place than when we got here. And one social problem that you all know about is problems with Black Americans' treatment by the police. So this is a problem that Black Americans have long reported: unfair stops by the police and negative interactions. And we know that police force, inappropriate use of police force, has been captured in famous cases like the George Floyd killing, where we've seen these viral videos. And we want to know, for this particular problem, can natural language processing help? It's like kind of a big ask. But could we maybe measure problems in police community interaction? Could we detect potential for escalation, potential for violence? Could we help even design interventions to help solve this important social problem? And our idea was that we could use body-worn cameras as data. So we look at one major police department. We're talking to other departments in progress. And we're going to look at just common everyday interactions as recorded on these cameras to ask how looking at the language of these interactions could help solve some problems. And we do this with a very large, very interdisciplinary team. So the PI of this team is my friend Jennifer Aberhart. She's a faculty in psychology. She works on race and criminality. And then each of the papers I'm going to talk about is led by a different former student, now faculty. This is a long-running project. So Rob Voigt is now at Northwestern, and Nick Camp is at Michigan, and Eugenia is at Virginia Tech, and Vinod is at the ethics team at Google. And so the team has psychologists and linguists and computer scientists and electrical engineers, and it's an amazing group of people. And so just background in the field, if you're going to learn about computer science applied to the criminal justice system, is the idea of procedural justice. Procedural justice is a concept in criminal justice. And it's the idea that the justice system should strive for not just equitable outcomes, so not just the right things happen at the end of a case, but an equitable process, meaning interpersonal treatment. So the idea is that, for example, police officers who are an arm of the law should treat people with respect. And it turns out, as a very practical matter, that if people are treated with respect, they also are more likely to trust the officer, to trust institution, and everybody comes out happier. So in our first study, we asked a very simple question. Looking at these body camera data, do police officers treat Black community members with a different degree of respect than white community members? This paper was led by Rob Voigt. And what we did in this paper is look at every interaction in 1 month, April 2014, about 17,000 videos. So in the city we looked at, every officer is required to turn on their camera whenever they're talking to a member of the public. So we have every interaction between an officer and a member of the public. And from that 17,000 interactions, our idea was, let's just look at everyday things, no shootings, no arrests, just everyday behavior. So we picked from that just traffic vehicle stops. and we picked 1,000 of them, and those 1,000 stops, all the stops with black and white drivers, lots of different officers in the stops, 200 different officers. And this is what the kind of data that we're going to use for the first few studies. So this is just a transcript of an officer, the very beginning of a conversation with an officer talking to a female driver. And so the officer talks to the dispatcher, we're going to ignore that. And then the officer says hi, and then she says hi back, and he tells her why he pulled her over, and then they're talking about the paperwork and so on. This is a normal interaction. We know the time they occurred, and then we have the officer's speech. And what we're going to look at in the first few papers is just the blue stuff: speech by the officer, not by the driver, and speech by the officer to the driver, not the officer talking to the dispatcher. How do officers talk to people that they stop? And so what we did in our first our pre-study is we took utterances by the officer and we just had humans label them. And we asked them, how respectful was the officer in this utterance? So the labelers would see what the person said, what the driver said, and then the officer said the following thing: how respectful was the officer's sentence, and how formal was the officer behaving? So we got labels for formality and respect. And I can talk about the details of the experiment, but I'm going to talk more about the computational side. But the human experiment exposed an important difference, which is that officers were equally formal to black and white drivers. They were equal sort of authoritative, but they were just more respectful to white drivers. So this is a problem, but like any social science problem, so as we're thinking about, as computer scientists, how can I work on problems that are complex and involve people and are social? Whenever you have a social problem and you have a finding like this, you should ask yourself, do I believe this finding? What are the confounds that could accidentally be causing my results that are not really, that are affecting my result in ways that are different than my prediction? So when we're doing, natural language problems, we often don't have a million confounds. When we're doing social problems with people, there's a million factors that could maybe be causing our result. So the first thing you want to do in applying AI algorithms of any kind to a social question is find out ways that we can control for all the various possible confounds. But the problem is we had humans label 400 utterances with 400 observations. Statistically, it's not possible to control for confounds. So we would like to look at lots of data. And another reason for looking at lots of data is there's 26 million traffic stops a year. If we'd like to understand how this happens across departments or in different places, we obviously are not going to hire people to listen to label each of our individual sentences for respect. We'd like to automatically label them, and now we could control for all the different confounds. So here's the idea. We have some human labeled data for respect. Let's train NLP models. We're going to build linguistic theories of respect to develop some features. We'll learn some feature weights, and we'll just build a classifier, and now we can have respect labeled for every officer. So if you learn nothing else from today, you should learn something about linguistic theories of respect and politeness. So the fundamental concept of respect, as measured in the social sciences, is this idea called face. And this was developed by Goffman and Lakoff and Brown and Levinson in the 60s and 70s. And the idea of face is that everybody has positive and negative face. Positive face is addressed by positive politeness. Positive face is my self-image. I think of myself as a good person. Negative face is my freedom of moving around. And we use politeness whenever we threaten our faces. So if I say, Kaiwei, get up, that's very rude. I've threatened his ability to move. That sounds very rude. Doesn't that sound rude? It sounds rude because I'm forcing him to do something. So negative politeness, all languages developed mechanisms to deal with negative politeness. So I might say to Kaiwei, oh, could you just move over a little bit? And so I'm minimizing my request. I might say, oh, I'm so sorry to bother you. Could you move over? I've mentioned my imposition. I know I'm imposing on him. Or I could say, oh, Kaiwei, I dropped my pencil under your seat. Could you move over for a second? So I've given you lots of softening ways of softening my request. That's negative politeness, very common in language. All languages do it. Positive politeness is the kind of thing you normally think of as politeness. I just say, oh, Kaiwei, you're such a good friend. Could you move over? So I'm emphasizing my value with Kaiwei. Okay. So that's positive politeness. And we can see both of these things in these kind of police conversations. So an officer can say, oh, I'm sorry. An officer can talk about their gratitude. An officer can say, oh, I need you to do this fix-it ticket. It's just a small thing. Don't worry. It's all going to be fine. I can use these things called hedges in linguistics. Just I have a little thing. I need you to sign this thing, and then check off that you got your light fixed, and so on. So these are all negative politeness things officers do. And officers can do positive politeness things. They can call drivers sir. They can introduce themselves. I'm Officer X. They can say drive safely. They can talk about the safety of the driver. And we have showed in previous papers that it's possible to detect these kind of politeness in all sorts of domains. So we did this online for question systems online to ask who asks and answers questions about computational things, and discover things that are not shocking. So Midwesterners are indeed more polite than people in other parts of the country when they're asking questions. Alas, Python programmers, of whom I am one, are the rudest of all programmers. That's a very sad thing. You will probably not be shocked to know that women are more polite than men. There's lots of gender theory explaining why that is. And you will be sad to know that we also found that power corrupts. So if you look at Wikipedia editors, right before they get elected to admin, they're really polite. And right afterwards, they're really impolite. So as soon as they get power, they're like, that's it. So we can measure these very practical social things online with politeness. So we built these same kind of classifiers for the police data, and we just run it on utterances by the police, and we can get it just a score. There's just a regression score. So how polite is the officer? In that first sentence, the officer is apologizing for stopping, introducing themselves. That's pretty polite. In the second utterance, they're also calling the person ma'am. They're saying please. They're telling them to drive safely. They're concerned about their safety. That's even more polite. So bless you. So officers are pretty polite. Now that we have a score, we can just run this on all sentences, and we can ask, is there an original question? Is there an effective race? Are officers respectful in different ways to different races? And the way we answer this, and it's a standard thing when you're applying NLP to any social science question, you run a big regression, and you run what we call linear mixed effects models, and social scientists call hierarchical models, but it's a regression with various hierarchically nested factors. And then you put in all the confounds into this big regression, and then you ask the question, is there a race difference after controlling for all these confounds? So I'm going to jump to the results, and then we'll talk about the confounds. So result one is officers are more respectful to older drivers. So that's kind of nice for me. I'm turning 60 next month. I'm older, and officers are nice to me. That is really nice to know. Alas, they're also nice to me because I'm a white driver. Officers are nicer to white drivers. That's not so socially good. So let me give you examples of things that officers do to white drivers. They are more likely to call them sir or ma'am or Mr. X. Officers are more likely to use those polite terms with white drivers. So, okay, ma'am, do you have your registration, ma'am? They're more likely to talk about the safety of white drivers. So drive safely. And this one, which is so great, the officer says, I'm glad you're safe. I just want you and your baby to be safe. That is such a great thing for an officer to say. Not so great that they say it more to white drivers. So that was all positive politeness. What about negative politeness? So that's like, no problem. I understand. I just need your driver's license. Don't worry about it. Just get this signed. And here's a case. This officer just have everybody just sign just prove that it's okay. So the officer is just kind of stumbling all over themselves to minimize this imposition on the driver. Again, a great thing for an officer to do. Not so great that it happens more to white drivers. Okay, so whenever you're doing social science, you should think skeptically. Maybe this finding is a finding caused by some confound. So what could the confounds be? Well, maybe this isn't officers being generally nicer to white drivers. Could it be that it's an effect of officer race? Maybe this is what we technically call homophily. Maybe black officers are being more polite to black drivers and white officers to white drivers, and it just happens that there's more of one or the other, and it looks like a race effect. So we look now at, I'll show you a graph where we look at the average respect for different officers of different races. Along the x-axis is respect, and on the x-axis, I'll show you differences of respect by race. How respectful is the officer more to white versus black drivers? And I show you three little graphs here: black, white, and other drivers. Other officers are Hispanic and Asian. And you see that there is three beautiful Gaussians lined up to the right of zero. So all officers of every race, on average, are just more polite to white drivers. It doesn't matter at all the race of the officer. Okay, maybe this is instead not caused by officer race. Maybe officers are more nervous in high risk, like say high crime areas. Officers are nervous. Maybe there are more black drivers in high crime areas. The officers are more nervous talking to drivers, not because of their race, but because of the crime, and that causes them to be less polite. So here's a confound that we might check for. How do we check for it? We'll look at the neighborhood the stop happened in. We'll look up the crime rate for that neighborhood. And luckily we have crime rates for all the neighborhoods in the city. And so we just code the crime rate as a factor. There is no effect of the neighborhood, no effect of the crime rate of the neighborhood. Maybe it's a gender effect. Maybe officers are more respectful to women, and it just happens there's a racial difference in gender. No, there is no effect of gender. Okay, maybe the problem is that very first study with the 400 human labeled sentences, maybe the problem is we did that study the way all psychologists do all studies, which, as you may know, is a terrible way of doing psychology. They require that people in Psych 1, every freshman, be in a study. So who labeled those sentences to say how polite the officer was? Freshmen at Stanford. Well, what do they know about, race and politeness? Who knows? So what we'd like to do instead is ask, what do drivers in the city where the study was measuring, what do those drivers think is polite from an officer? So where would you go if you wanted to find a perfectly demographically matched sample of all the drivers of a city? Any thoughts? The DMV. You go to the DMV, right? Excellent. The DMV is exactly, everybody has to go there in person. Perfect demographic match of every driver. You get it's a great sampling technique. This was thought of by Nick Camp, the author of first author of one of these papers. So we just replicated the study at the DMV. DMV has the advantage, there's lots of people waiting in line, happy to do a study for $10, yeah. So with this set of drivers, taking the study, looking at what sentences look polite and not polite, we get an exact replication. Doesn't matter the race of the person who's filling out the form, it's kind of clear to everybody what counts as polite behavior. So that can't be the reason for the racial difference we found. Maybe, here's another confound we should check. Could it be that the police are polite to white drivers because white drivers could be stopped for more minor offenses? Maybe the confound could be that officers are more annoyed at black drivers if black drivers commit more severe offenses, causing them to be less polite. And so it's not a race effect, it's an effect about the kind of offenses the drivers were stopped for. So to test this, we hired some police officers, and we just asked them to look at our 1,000 stops and code how severe the infraction was that happened in that stop. So, and we had the officers come up with this scale. So expired registration, not very severe, speeding, very severe, everything in between. And we just had them label every utterance, every stop. So now, if this confound was true, we would expect to see that black drivers are stopped for more serious offenses and white drivers are stopped for less serious offenses. But in fact, it's white drivers that are stopped for more serious offenses than black drivers. And this is a known fact that officers generally stop black drivers on smaller provocations. So this can't be the reason why officers are more respectful to white drivers. How about another confound? Maybe because we measured this by having officers read having the participants read the sentence in which the officer as words were laid out, maybe we're missing something about tone of voice. Maybe even if officers are more respectful in words to the white drivers, maybe their tone is more respectful to the black drivers. And we know that prosody, which is the kind of the pitch and the loudness and the duration of syllables, maybe these prosodic factors, we know they're an important cue to social meaning. We need to be able to measure those. So in a second study, I'm nesting now into a study just to check for this control confound, we asked if there's racial disparity in tone of voice. And the way we did that is we just cut out some officer speech and we low pass filtered it. So low pass filter is when you remove all the information that's above 500 hertz. So it sounds like what I think of as Charlie Brown adult speech, like sounds like that. And you play that for people and you ask them, how respectful was this officer? How friendly was this officer? And so on. And what subjects find is that the Charlie Brown speech that, although the subjects don't know this, was directed at black drivers, at white drivers, was more respectful and more warm and more at ease. And after controlling for the same factors we talked about earlier. So prosodically, ignoring the words, officers are more respectful to white drivers. We're going to skip this. Okay, so we don't know what causes these racial disparities. There's clearly a racial disparity. Doesn't necessarily mean individual officers are racially biased. So it could be, for example, that disparities might have some partial cause. The drivers might be saying something. While this is a partial cause, this can't be the major cause for our findings. And the reason it can't is that if you look before the drivers talk at what the officers say at the beginning, there's a racial disparity in respect. So what I'm showing you on this graph is along the x-axis is time. We've normalized all the different stops to 0 to 1. Along the y-axis, we have respect. And you can see that from the very beginning, blue is the white drivers and red is the black drivers, or blue, green, I'm green colorblind, but that top color, that officers are just more respectful to white people from the very beginning. And in fact, this disparity increases. Okay, so far I've talked about this very simple variable, politeness. It's kind of abstract. We'd like to look in more detail at the dialogue structure. And this was a paper led by Vinod Prabhakaran. And this relies on two linguistic insights that the NLP people in the audience will all know about. And so one is from Wittgenstein originally, the philosopher, who said, when we're taking a turn in a dialogue, each turn is a kind of action, a speech act, we call them. Every time I do something in a dialogue, I'm acting on the world. And a second important early NLP pioneer, Barbara Gross, who said, who found that she was studying how people do dialogues when they're trying to solve a task, like together we're trying to put a wheel on a car or fix something, that if the task has a structure, like first you have to take off the old wheel and put on the old wheel, if there's a structure to the task, it turns out the dialogue has the same kind of mirroring structure. So the idea is that there are going to be speech acts that people say that mirror the actions that the officers have to do. So here's another transcript of an officer talking, and they have to do stuff like greet the driver, they have to give the reason for the stop, they have to ask some details, maybe they'll issue a sanction at the end. These are all speech acts the officers have to do. We call these institutional dialogue acts. And it turns out that there's policy implications of these institutional dialogue acts. So departments require that drivers are told the reason for the stop. So they have to say something like, I pulled you over because you were talking on your cell phone. So maybe if these get delayed, there'll be some problems. Maybe people don't like it if they don't hear the reason for the stop. And another dialogue act with a policy implication is that black drivers have long complained they get asked investigatory questions like, is this your car? Why are you here? Why are you in this neighborhood? So can we measure and quantify this difference in what we call these legitimacy questions? So we built a dialogue act detector, a standard NLP tool. Here's just a few of the 23 dialogue acts, but the officer could give a reason for the stop. The officer could tell the person to drive safely. The officer could offer help. They could ask if it's your car, all this kind of stuff the officer can do. And for this study, which is still in progress, we we do our detection of dialogue acts straight from the raw audio. So in the first study, we use transcripts. In this study, we take the raw audio, we run it through a speech detector, we diarize it, we find all the officer's speech, we run that through a speech recognizer, we get out NBES list, which we now pass into a classifier, and we can detect the dialogue act for every turn that the officer says. And now we again run this on all the turns in all 900 vehicle stops, and we can ask if there's differences in conversational structure. And this is work in progress. What we're finding so far is that indeed, Black drivers are more likely to be asked legitimacy questions like, is this your car? Why are you in this neighborhood? And we see that when officers are more respectful and don't ask these legitimacy questions, it turns out that drivers seem less angry by measuring anger in the rest of the stop. And this still work in progress, but this initial finding led us to ask a question about escalation. So this is a paper that's under review right now, called The First 45 Words. And this was led by Eugenia Rowe, who's at Virginia Tech. And so in this study, we're looking at escalation. There's lots of calls for police to de-escalate encounters. So in particular, the killing of George Floyd led to the largest racial justice movement of our century. So, and this kind of worry about escalation can happen even when no force is used. So we want to know, how does this escalation unfold, and what kind of language characterizes what we're going to call escalated stops, which are stops where someone's handcuffed or searches or arrest. In our data, nobody was shot, nobody was killed. So luckily, we're going to define escalation by things that go wrong in less severe ways. And we're going to ask, what happens at the very beginning, the first 45 words, about half a minute of a stop? What happens at the beginning that telegraphs that there's going to be escalation at the end of the stop? And again, we looked at our dialogue acts. So we looked at did the officer give the reason for the stop? Did the officer give an order to the driver? Did the officer ask legitimacy questions? And here we look just at Black community members, because almost all the escalated stops in our data set, the driver was Black. So we looked at all the Black stops of Black drivers. And then to be very careful in this one, we ran our dialogue act tagger, but we also hand corrected all the dialogue acts. So we're positive these are the correct dialogue acts for the officer's first 45 words. And now we just ran a logistic regression asking, what happens when a stop later is going to become escalated? And it turns out to be stops in which the officer does not give a reason for the stop and instead just starts with orders. And in fact, just these dialogue acts and the officer's words gives NLP classifier about 70% accuracy at detecting whether the stop is going to be escalated. So you give me the first 45 words of a stop, I can tell you if that person's going to be handcuffed or arrested 10 minutes or 20 minutes later. What that means is that escalation, we've been calling this escalation. Things, bad things happen. It's not clear that they're building over the length of the stop. In fact, they start in escalation. These are stops where the officer starts out with an order, these stops start problematically. And they don't start problematically because there's some kind of warrant or a probable cause. In almost all of these stops, the officer said in their written report, I just stopped them because of a traffic violation. They turned right, they didn't stop at a stop sign. And if you ask, I'll go over this very quickly, but we did a psychological study where we asked Black participants to listen to these words and tell us how you feel about the officer, having heard the officer's 45 words. And what they say is that in these exact stops, the ones that became escalated, they would feel negative emotions, the officer behaved more negatively, they're pretty sure bad things are going to happen, and they're more worried about use of force. So yes, these outcomes are all influenced by these two variables. Does the officer begin the stop with an order, and does the officer give a reason or not? So in all of these cases, if an officer gives a reason for the stop and doesn't start with an order, the people are much more comfortable with how the stop sounds. So in other words, escalated stops begin because officers begin with orders that we can detect these escalated stops. Humans can detect them, NLP can detect them, and we can do this just from the very beginning. And these escalated stops, in these escalated stops, no force was used, but the same kind of signatures of escalation can happen when force is used. And I want to show you just the linguistic signature of one very prominent use of force. So this is the George Floyd case. So lots of people know what happened after George Floyd was pulled out of his vehicle. But I think very few people have seen the transcript to see what happened before he was pulled out of the vehicle. So here's the transcript of the officers talking to George Floyd. And in blue, I'm showing you officer language on the left, and on the right, the speech acts. So the officer says, "Let me see your hands." And Floyd says, "Hey, I'm sorry, I'm sorry." The officer says, "Let me see your other hand. I'm sorry, I'm sorry, I'm sorry. Let me see your other hand. Please, please, Mr. Officer, both hands. I didn't do nothing. Put your hands up right now. Let me see all your hands." So lots of officer orders about hands. Put your hand there. In the 10 turns where Floyd is talking, he apologizes. He asks why I'm being stopped. He says, "I didn't do anything." He tells the officer why he's afraid of being shot by the officer. He interjects a lot. He pleads for his life. And in all 9 turns, what the officer does in response to Floyd's actions is give him another order. So in other words, officer language signals this trajectory that's detectable to Black drivers and to NLP systems, which is that bad things could happen to me from the beginning. I can sense that these things are not good. This kind of force is rare, but our data on the psychology of Black drivers suggests that they're worrying about this use of force. And this worry alone, even in stops with no force, can drive these negative encounters. So right now, no police departments in the United States do any review of their body camera footage. So this is the first time any researchers, we're the first lab that's looked at this body camera footage at all. So this sort of calls for, there's an enormous amount of information that computer scientists and psychologists together could find in this data. Okay. Lots of problems, but can we help solve them? Like the goal in using NLP to work in the world is, could we actually make things better? And the obvious way to look at this is to look at police training. So could we train police to use less of this negative language, to be equally respectful to white and Black drivers? And the problem with this is that bias training, which we all have to take, is known to be very difficult to do well. Lots of work has shown that bias training has limited effects, that it often doesn't lead to behavior change, and partly it's because existing trainings were just hard to do well. And so what we did is run a very careful behavioral training where officers were shown actual transcripts of, this is an interaction that went well, this is an interaction that went poorly in your department last month. This is how we should talk, this is how we should not talk. And then after the training, officers were evaluated 3 months later by looking at their body camera data to see how they talked with drivers before and then after training. So we have recordings of officers are randomly assigned to take this training, and then we have recordings before and after to see how they behaved. And this is what we're in the middle of studying right now to see if that helps. We're also in the middle of looking at the driver language. So what is the driver language like? Do drivers admit to fault? Do they explain what they're doing? Are they asking a lot of questions? What does the driver look like? We're also looking at other police departments. We're now doing more speech recognition on the data. We're looking at other kinds of stops from officers, like pedestrian stops. But our results so far are that you should take away is that Black and white drivers see very different interactions with the police than each other. White drivers tend to be spoken to with respect. They have their safety talked about. Black drivers are spoken to with less respect. They have their legitimacy challenged. That these differences have implications for escalation. that linguistic measures and NLP measures for studying these things are important and can help, and that improvements in training might help address this problem. Okay, I want to turn to a second problem altogether. So, and then at the end, you can ask me questions about either one. So, in the second problem, I want to talk about how do we measure framing in US political speeches? And this is a study led by Dallas Card, who's at the University of Michigan. And again, very interdisciplinary paper. This one began when Leah Bustan and Ron Abramitsky, two economists, came to us. The first bunch of studies came about because Jennifer Aberhart, a psychologist, came to us and said, can we do NLP to help analyze this data? And Leah and Ron had the same question for us. We have this economic questions about how immigration, the history of immigration, could NLP help? And what they pointed out is that there's lots of deep historical roots to the current rhetoric about immigration. So if you read a senator from 2018 and a senator from 1896, you get almost the exact same words about floods of immigrants. So Henry Cabot Lodge, the flood of low, unskilled, ignorant foreign labor, by which he meant Chinese. Henry Cabot Lodge was arguing that we should stop the immigration of Chinese people. Jeff Sessions making the exact same argument a couple hundred years later. 120 years later. So we see this rhetoric all along, but we don't know if this is just a couple of outlying senators, what really is happening. So the question posed to us by the economic historians is, could we look at the entire history of congressional speeches and look at how Congress people talk about immigration to understand at least the political understanding of immigration? And so we're going to look at three things: changes in attitude and polarization, different kinds of framing, and I'll introduce a really cute NLP method for measuring what I'm going to call dehumanizing metaphors. So first, we're going to just do standard text classification. We're going to talk about this idea of framing lexicons, and then we're going to measure dehumanization. So first, we want to just measure every speech. Is it about immigration, and is it pro or con immigration? And that is a standard NLP task. We just fine-tune a Roberta classifier for is this speech about immigration or not immigration, and is it pro-immigration or anti-immigration? Sample classification task. And so we run this over the 140 years, and I'm showing you the average percent pro minus percent anti. So up means pro-immigration, down means anti-immigration in speeches given by Congress people since 1880. And you can see that kind of from the early phases. So 1882, sorry, is the Chinese Exclusion Act. So that's the act by which all people from Asia were excluded from the United States for the next 70 years. So from that period, Congress is very negative about immigration. There, in 1923, that exclusion was extended to all, so Jews from Eastern Europe, Italians from the south of Europe, everybody who was not from Northwest Europe was unable to immigrate after 1923. No change during all this period. So Congress is very anti-immigration. Finally, you can see after World War II, there's a big change in congressional sentiment. We think it's due to the refugees after the war. There's a World War II, there's lots of refugees, there's more positive sentiment toward immigrant refugees. All of a sudden, the nation gets a little more positive. The quotas repealed in 1963, so people from Asia, Eastern Europe, and Southern Europe are allowed to come again. And then right now, I'm showing you split by the political party of the Congress people talking, and you can see that all the way up until about 1970, 1968, there's no party difference in how Democrats or Republicans talk about immigration. It's not a party difference at all. Congress is just anti-immigration, and then they're all of a sudden pro-immigration, and then a little bit in the late 60s, but really, around the time of the Reagan administration, huge splits between Democrats and Republicans. Democrats stay in this positive vein that's happened after the war, and Republicans start getting negative again, to the point where an average Republican today is about as negative on immigration as the average congressperson was in the period of mass migration when the anti-Chinese laws were passed. We can look at how, look at the different countries. So the three biggest immigrant groups in the speeches, Italy, China, and Mexico. And you can see that, that very quickly, right around the war, Italian immigrants were talked about very positively all of a sudden. And Chinese immigrants were talked about less positively than Italian immigrants, but certainly positively. And Mexican immigrants kind of up and down, and to the point where now, on average, Mexican immigrants are talked about negatively in Congress. So big differences in where the people are coming from. Okay, so that's our first simple NLP classification with Roberta. Second task is, can we understand what the Congress people are talking about these immigrants? So the standard method for this is topic modeling, a latent Dirichlet allocation. Topic modeling is a NLP tool that's really common in the social sciences. Didn't work well for this data. So instead, we did this thing called framing lexicons. So here's what you do. You find a sentence that mentions an immigrant, and you parse it, and now you take all the words that modify that word immigrant, all the verbs that's the subject of, and all the adjectives that modify it, and you take all those words, do some log likelihood ratio test to get the frequent cases, and now we curate them by hand. We label them into 14 topics. So all the authors of the paper labeled every word for what topic it was in, and use embeddings to clean this up. And now we know what the Congress people are talking about in these immigration speeches. And now we can look at how that differs by time or by race. So on the left, I'm showing you a graph where along the x-axis is how much are people talking about this particular framing. Are they talking about immigrants with regard to crime, or with regard to legality, or as a threat? And the size means the more people, and to the right is positive, to the left is negative. And you can see that there's no big party differences. To the right is Democrat, and to the left is Republican. You can see that in the early period, around the turn of the 19th century, there's no party differences. By the turn of this century, the last 20 years, you can see big racial differences big party differences in topic. So Republicans talk about immigration in terms of crime, legality, threat, and Democrats talk about immigration in terms of family reunification and refugees and victims and the contributions their culture is making, and so on. Oh, I just said that, yes. Okay, and then, so there our third NLP task is to understand metaphorical dehumanization. So this relies on a long linguistic literature that talks about the concept of dehumanization. So here's the idea. If you use a word like flood or wave or stream or pour to talk about people, like this flood of immigrants streaming in, it's implicitly invoking the metaphor that these people are kind of a natural catastrophe. These people are a natural force. They're not people individually. They're just this thing that's attacking our country. So this idea of metaphor, popularized most by George Lakoff, talked about this idea that the implicit language we use implicitly brings up metaphors that are very hard not to think of when you see these words, even if you don't say them explicitly. So if I say things like, they shot down my arguments, or I never win an argument with you, or he attacked my argument, we're thinking about an argument as a war. Even though I don't say the word war, these implicitly are giving the metaphor that our things we argue with war. Or if I say, my new app is going to save you hours, and I don't have any time to spare right now, or that tire cost me an hour, we're implicitly talking about time as if it's money. None of these things say time is money. These are implicit metaphors that frame the time in that way, or frame argument in that way. So we looked at the literature, linguistic literature, that talks about how people can be dehumanized, or they can be talked about as animals, either with or without the word. So the simplest one is disease. You can talk about people as a disease by saying immigration is a disease. That's very literal. Most of the time, people aren't so literal, so they'll use the flood tide metaphor. Immigrants are like a natural force. They're flooding and streaming in, or you can say literally immigrants are like rats, or you could say implicitly they're swarming. So Congress people are much less likely to use these very explicit words like calling people vermin or animals, but they're much more likely to use these kind of dog whistles, these implicit ways of talking about people. So we'd like to measure these implicit dehumanizing metaphors. And here's the idea. We take a text that describes an immigrant and we mask out, we're used to masking in NLP, we mask out the word describing the immigrant. And now we ask the model, give it the model to one of our large language models and say, what word do you think that was? And we ask if it's one of these words like vermin or disease. And we just count up all of those vermin or disease synonyms and get a probability that this model thinks the person was implicitly using that metaphor. So we have our list of words related to these commonly mentioned dehumanizing metaphors. So we're going to ask Bert, how likely do you think that missing word was rat or worm or bug or so on? Or how likely do you think it was animal or beast? So let's take the metaphor of cargo, where we treat people as if they were cargo being shipped. So the sentence we took was prevent the dumping of undesirable aliens into this country. Mask out the word aliens, and now pass it through Bert, and now take the mask and ask, what's the probability of any of the words having to do with cargo? And if it's high, that gives us the probability that this sentence was implicitly about this dehumanizing idea of cargo. And what you can see is that there was dehumanizing metaphors were not that there was no party difference 100 years ago, but now there's a very large party difference. So the dehumanizing metaphor is much more likely to be used by Republicans, and you can sort of see the big shift right around Reagan administration, maybe a little later, maybe even in the late 1990s, where there's a huge rise in this dehumanizing description of immigrants by Republicans. Finally, you can see a really interesting homology. So these are, remember, the same frames we talked about before. On the left, I'm showing you the difference between how Congress people talked about Chinese immigrants and European immigrants. So to the right is how Chinese immigrants were talked about, to the left, how European immigrants were talked about. And you can see that Chinese immigrants were talked about as being a problem with labor, being illegal, that we need to exclude them, that they're a threat, that they're committing a lot of crimes. This is exactly how Chinese immigrants were talked about. That led to the banning of Chinese immigration to the United States. And on the right, you can see how Mexican immigration is talked about in the last 20 years. The exact same metaphors are being used. So Congress people today are talking about Mexican immigration of the last 20 years exactly the way Chinese immigrants were talked about 100 years ago. Okay, so lots of facts about immigration we can learn from these studies, and three interesting kind of NLP tools that we can use to help understand this important social problem. Okay, I want to finish on some discussion points. So this is from the computational perspective, most of what we're talking about is standard NLP tools, embeddings, BERT, we know how to build classifiers, topic modeling. We have a few new tools I introduced, like this neat new metaphor metric. Most often, though, the questions we're asking come from the social sciences. How has immigration changed? How do our attitudes change toward immigration? How do officers treat Black versus white drivers? These are questions that came from the social sciences, and we as computer scientists are trying to help answer them because we have the ability to analyze this kind of data. So the collaborations with social scientists are pretty essential in this work. Occasionally when I write papers, I'm the social scientist because we're studying linguistics, studying language change, and then I act as the social scientist. But more often we're going to economists and political scientists and sometimes humanists and so on. The theoretical ideas might come from linguistics, but often it's really hard to know whether the paper is about this new NLP method, whether it's about the scientific finding. It becomes very difficult for students to know where to publish. I've talked to some of you about this today when I talked to the students. This is a general problem with interdisciplinary research. we're discovering facts about the world that are theoretically interesting using a new NLP method. Who should we tell about it? And so sometimes the answer is we tell both communities, we write 2 papers. And I want to leave you with just a high level thought about how we should think about language processing, which is that the common misconception is that language is about words and what words mean. And it doesn't. It has to do with people and what people mean. No, I'll leave you there with it, for time for questions.
Thank you very much for a great talk.
And it's okay to leave the recording on for questions?
Yeah.
Okay, great.
Any questions?
Thank you for the amazing presentation. I have a question for the researching one. So, does the study taking into has the study taken into more pragmatic effects into consideration, such as you know, when the police makes a request, such as can I see your trunk? Do black drivers tend to feel more colors than white drivers in that situation?
That is a great question. So just in case you couldn't hear the question, it was when police ask drivers, can I open your trunk? Do black drivers feel more coerced? In general, how do people feel about, so people have the right to, those are called consent searches. And you all have the right to say no to a consent search. Are there racial differences in this? So actually, we're very interested in consent searches. It turns out in the department we looked at, there were very few consent searches. In this data set we looked at, there were a lot of searches, but they were from people who are on probation or parole, and they can be searched without their consent. So we'd like to look at this, and we're trying to get more data in which we could ask about consent searches. But the linguistics of this are very interesting. What makes someone, when does someone feel free to walk away from a police encounter? How do you know if you're being stopped? How do you know if you have to say yes or no? Citizens, we're not often taught that in civics classes, and non-citizens, how would they know? And so these are great questions. Yeah.
Thank you for coming for this talk. It was really excellent. I had a question for your police example. So it seems like really quickly into the conversation, you said after 40 words, you can tell someone's going to get arrested after their encounter with the police. Has there been like work to maybe create like a script that gets like a positive tone of the conversation between the cop or they stop, just so like the conversation has a better chance?
Yeah, it's a great question. So yeah, since we found, just repeating the question, since we found that that the first 45 words matter so much, why not just make a script that officers could start with? So in some sense, the training, which was based on the results of our first study and not yet on that study, which wasn't finished yet at the time, does some of that. It gives instructions for officers on best practices in doing a stop. You have to give the reason early on. You have to introduce yourself. So it does some of that, and we're still analyzing the data, but it's looking like that does help. And what you're suggesting is, even more specific, like give a script. Officers like to have some discretion. So I suspect that training that says you must use these words in these orders are unlikely to be acted on well. But I think you're right. Some indication of what to do and what not to do, and that's sort of what we did in the first training, I think is exactly the right answer. Yeah.
Yeah, for the immigration study, so you have the models look at sentiments back in like the 1800s. Do you worry that like since the models are training today that the use of modern language could be different?
Yeah, great question. So so the question was, since we're doing sentiment analysis for the immigration study for 140 years ago, how can we use modern sentiment analyzers? And the answer is that's a great point, and we can't. So there's a number of things that we've actually studied in previous papers. So you can do things like take your model, if you're doing lexicon-based sentiment analysis, you can take a lexicon and project it back into the past. And there are various ways to do this, but the simplest one is you train embeddings on all your years, and now you take your modern sentiment lexicon and you look at the embeddings for that in 100 years before and look for outliers and words that have shifted their meanings and remove those from the set. And if there's some inliers, like words that used to be the right word, so you can basically shift your lexicon if you're doing lexicon-based sentiment. In our case, we also had humans label past immigration speeches for pro versus anti and new ones. So we could tune our models on data just from that period. Yeah, that's great. Whenever you're doing any of these kind of things, you want to think about how to move your data to that distribution. Nice.
Thanks for giving a really engaging talk. Also on the line of the police, I'm curious how easy it is to work with police to get departments to give them feedback. Like I know journalists often have like FOIA, all these things, and now police are turning off their body cams and interactions. Has it been easy for you to get this stuff and give them feedback, or is it kind of a?
Yeah, great question. So the question is like, how easy is it to get police to be cooperative and give us data? So the answer is it's very difficult to, in general, get access to this kind of data. So some police departments, the chiefs are very willing, like know there are problems in the departments. Sometimes the departments are under consent decrees, so they're required to do something and have people look at the data. So sometimes you get a forward-looking police chief who are willing to have researchers look at the data. That's happened to us a few times. It's rare. My colleague Jennifer Aberhart, works extremely hard at this, at convincing police departments that she's a fair researcher, that the results of this thing can help make the department better. And she has some success in it, but even for her, it's taken many years. I didn't mention how difficult it was to work with the data. So to work with this data, because think of it, it's very sensitive data. This is everybody who's ever been stopped by the police. It's their names are mentioned, their driver's licenses are mentioned. So, were they stopped for alcohol? Like these are very sensitive. So every single person has to be background checked by the department and the FBI, every grad student, every transcriber, so that when the data is transcribed, those transcribers have to be flown in to the department, background checked by the department, then flown home. So it took many years to deal with all. This project started in 2014. So it's been 7 years and we're slowly getting the papers written. So you have to really be committed. Helps if you already have tenure. Yeah.
I also have a question about the body camera data. So
Yes.
It sounds like, with the body camera data, we have a body camera component to it. And so it looks like in all the studies presented here, we've always been working with audio and text. So is there a reason for not using the?
Yeah, great question. Why did we look only at the audio and not the video? Mostly because I'm a language person, and also the questions we thought of were mostly questions that could be answered from the text. But yeah, the video is there, and there are many computational tools. So, like for example, we need to do a better job of diarization. That's the task of who's talking: officer talking, driver talking, officer talking, officers talking to another officer. So it's diarization is the task of who's talking. Addressee detection is who they're talking to. And all of those classifiers could probably be improved by video. We could also, if we had video, we could ask about the nervousness of the driver, where are their hands, all these questions about the scene. Now, all the ones at night, the videos are very blurry. And so it's extremely difficult. So bless you. So difficult, and partly I'm just not an expert on it. So yes, I suspect we'll get to the point where we have a great question that is a vision question, and then we'll like, somehow bribe our vision scientists to come work with us. Yeah. Yeah. Yeah.
For instance, for this slide where you had two graphs and it was Democratic, Republican across time, and the populations of European, Chinese, European, Mexican.
Yes.
Yes. Were there any difficulty dealing with the sample size of data? Because I would imagine from my impression, not all of these immigrants are talked about the same amount.
Yeah. Oh, yes, absolutely. Yes. Yeah. So you can see some of that. Well, the size shows how they're talked about, like the frequency with which a particular frame is used. But that's not your question. Your question is, well, suppose there's less discussion of Chinese than Europeans. So yeah. So you have to always normalize. The answer is normalization. So these are log frequency ratios where it's how often out of the times a Chinese person is discussed is frame X used. So we always have to normalize for sizes. Yeah. And sometimes, in general, there's also more speeches now than there were back then. So when you're comparing across time, you have to, there's some tricky questions about stability, but roughly speaking, we just always normalize, and I hope that gets most of it. Yeah. Yeah. Lovely question. And there and then there.
Okay. Yeah, my question is,
Thank you for the talk, by the way, but I was wondering, would you be able to in the future package up the tools that you use and give it to a police department so they can check over time if the police department is improving on these various metrics that are mentioned?
Yeah, I think that's a goal. I think chiefs would like that. They would like such a tool. The real answer why we haven't is just really hard. Like all of this takes 10 PhDs working together to figure these things out. And I guess our hope is if we publish enough of this and make our methods clear enough, yeah, some company might come along and want to do these things. There are companies that, for example, take the body camera data and specialize in doing speech recognition on them and giving the transcripts to departments. So that's not yet useful to them, but you could imagine tools in the future. So I think, yes, somebody could do this. And I feel like once we've done enough research where we feel like the tools are stable, that's the kind of thing I could imagine someone doing. This side, because I was always on that side. Yes. Yes. Yeah, for data set. So the question was, is the data set from human transcribers? For the police study, we've done both, is the answer. So for some questions, we've tried to use speech recognition, and we're in the middle of now, this is my year when we're trying very hard to get the speech recognition, because now there's Whisper and there's Wave2Vec 2. So there's now much higher quality speech recognition in 2022 than there was in 2014 when we started. When we started, we tried to use speech recognition, it just wasn't good enough. But it's good enough for some things, and I think now it's going to be better. But for most of the studies I reported, for that reason, we used hand transcripts, and that's why we had to fly people in. And so we're hoping to avoid that in the future because it's time consuming and it's also very expensive. Like transcription is really expensive, and ASR is supposed to help us avoid that. Yeah. Oh, excellent. Yes. Yes, question. Yes, because ASR systems are biased. So we have papers on this as well, that speech recognition systems don't do well in African American English, and so those biases have to be taken into account if we're using recognition. Yeah, that's absolutely true. It's also true for transcribers who are worse on African American English if they're not African American. So that's another problem. But yes, something we would have to deal with for sure.
So for example, like include audio features, like adding to the textual features, or just directly using this NTX speech model to train classifiers.
Yeah, great question. So we just separated out speech and audio into two studies, partly because I think this is how, like, what you asked was, well, why don't you just combine the speech and audio into one thing and build one big classifier? And I think I think I would think that way as a computer scientist. I think psychologists would think you're mudding everything together. I don't know which thing is causing the effect. And while we could look at which features are more significant, but I think it felt more natural to separate these questions out and ask about prosody differently than tone, because now you can ask, okay, what about the prosody is causing the effect? We can look at the actual pitch traces and things. Yeah, so I think that's why we separated them out. And then you had a second part to your question, which was, yeah, so I think if we were building a respect score now, we would probably do both. Like if my job was, let's say, to answer your question about building a tool for the police departments to measure respect, I would, yes, for sure throw in all the features. The modern way to do that, like not 2014, but 2022, yeah, I would throw in everything into some big, pre-trained text and speech pre-trained model, and yeah, build a single classifier. That's the right way to answer that question, which is, how respectful overall, give me a respect score. Yeah, I mean, would a police department or would a city council accept like one number? Might be trickier. Like the more we build black box models, the less for a public policy decision. We've seen this with bail and with all these other things, that if you give a politician a black box or a community a black box model, it's not clear if they're happy trusting the answer, and maybe they should question the answer. So these are great kind of questions at the intersection of policy and AI. Yeah.
Is there any selection difference of what the base camera requirement? Maybe instead of kind of the insurance company, we don't want to share some data, some certain data, for example, they stream data.
Yeah, could there be bias in the data because the police department hid some data from us? It's technically possible. So data comes in buckets like arrests. You know, the files on arrests are kept in different places than the files on non-arrests, and so there's certainly different sources of data. I'm sure we missed some data, like some data got missed in passing around. As far as I can tell, we don't see any obvious attempts to hide, partly because it's not clear what they would want to hide, because the data is, there's like a data room, you know, with lots of disk drives full of uploaded videos and with IDs, and that are matched to a stop form that has an ID and sometimes not matched. There's a lot of just raw data, and then we just got a data dump. So I think I don't think anybody knew enough to separate out part of that raw data, would be my guess. Yeah.
Yeah, I'm just this might be a simple question.
Okay.
But how generalizable is stuff like politeness and prosody to different dialects of English? Like I imagine there are different cultural norms around what's polite, or if like a swear word is cordial or antagonistic. Like, is that something that you have to retrain your model?
I would retrain a model. Yeah, politeness is cultural for sure. And so, yeah, for different dialects of English, yeah, I would think about the model differently. So, for example, our model, we ran it on officers, not on the drivers. Officers tend to speak very standard English, even if their native dialect is not that. They're in their role as officers, they tend to speak standard English. And yeah, if I was running this on community members, I would think a lot about the dialect of the community member first. Yeah, you would expect, and it'd be very hard because we don't know who the community member thinks of themselves as. So, you know, what is their native dialect, and that's quite hard. Yeah, nice. That's a nice problem.
Yeah, so compound factors, the variables that you can consider. How do you decide when to stop? Vectors.
Yeah, it's a great question. Like when you're doing the social sciencey stuff and there's all these possible confounds, how do you decide when to stop putting in confounds? But partly like a confound, if you think about it, like anything could be a confound. We could have put in whether it was a full moon as a confound. Why did we not put in a full moon as a confound? Well, okay, werewolves maybe are involved, but probably not. And so a confound has to come from a theory. There has to be a theory that would explain this, and the theory has to be a sensible theory you could imagine defending. So that helps somewhat, but there's still a million things we could put in, and we basically put in everything we could think of that we could measure. So there are some things we couldn't measure, and some things we probably didn't think of, and some things, you know, reviewers will be mad at us and say, here's one more you forgot. And I think that's the case for all social psychology and social science papers, that the major thing that reviewers are doing is finding confounds you missed and asking you to go back and control for them.
And then like some obvious factors that you should.
Well, you think about confounds when you're collecting the data, the obvious one. So for example, if you know gender is going to be a confound, let's say, and your data is almost all men, then that you're not going to be able to measure that confound. And so in such a case, you might decide to only look at men, or you might decide to do a separate sub-study where you balance men and women or something. So when you know, or other genders, I mean, not just a binary case, whenever you have a worry that you can't measure something, then you can't use it as a confound. So you do have to think about the confounds in advance. You don't have to do the work to measure them, but you have to know that the data is available for measuring them. But then, yes, you run the study, and then you do all of the confound studies in a big, usually you try to put everything in a big regression because confounds influence each other, complicated by facts about regression that, you know, if the variables are collinear, you can't put them in the same regression. You have to regress things out of each other. There's, you know, standard social science, fancy regression things you have to do. Are we good on time? Okay, yes.
So for the first study, you mentioned that the important part was to use the results of the study to actually implement change. So I just was wondering for the second study, are there any steps being taken, or is it more of a kind of a theoretical?
The second study, we could do more police training based on the results of the second one, which we could modify the results of the first training to take into account this fact about behavior. But in the second study, oh, you were talking about the immigration study. Sorry. Oh, yeah, the immigration study. Oh, boy. No, I don't feel like I don't feel like we've learned anything that would help us make congressmen less racially differentiating in their attitudes toward immigration. Yeah, that would be great if you think of anything. Yes, I think yeah, that would be great. Yeah. So it can't always help. Yeah.
Let's think of Professor John.
Okay, thank you.